Hello, and welcome to the Deep Space Relax channel. Tonight, we will set off on a calm and soothing journey beneath the waves, discovering 100 astonishing facts about the ocean, a vast and mysterious realm that covers more than 70% of our planet. From ancient shipwrecks resting quietly on the ocean floor to creatures that glow softly in the dark and underwater mountains that rise higher than mountains on land. The ocean holds wonders that are both breathtaking and unexpected. So lie back, breathe deeply and slowly, and allow your thoughts to drift like gentle tides as we reveal the secrets of Earth's largest habitat. Whether you are here to relax, to learn something new, or simply to fall asleep, these peaceful stories and captivating truths will guide you into a calm and restful night. Let us begin. There are more historical artifacts underwater than on land. When most people think about history, ancient ruins and priceless artifacts usually come to mind on land. Yet the ocean contains far more historical treasures beneath its surface than all land areas combined. Over thousands of years, countless ships have sunk, harbors have been submerged, and entire cities have vanished beneath rising seas. These underwater locations preserve artifacts in surprisingly good condition because low oxygen levels and stable temperatures slow the process of decay. Examples include sunken Roman cargo ships and the submerged city of Pavlopetri in Greece, which is considered one of the oldest known underwater cities. Modern technology, such as sonar mapping and advanced underwater robots, is now helping archaeologists uncover these hidden time capsules, revealing enormous chapters of human history that have remained concealed for centuries beneath the waves. Some jellyfish can live forever through biological immortality. Unlike most creatures that grow old and eventually die, certain species of jellyfish can completely avoid death through an extraordinary process known as biological immortality. The most well-known example is Turritopsis dohrnii, often referred to as the immortal jellyfish. When faced with injury, stress, or the effects of aging, this jellyfish has the unique ability to transform its cells back into an earlier stage of development, effectively restarting its entire life cycle. This process, known as transdifferentiation, allows the jellyfish to revert to a polyp-like juvenile form before growing once again into adulthood. Because this cycle can repeat endlessly, these jellyfish have the potential to live forever unless they are killed by predators or disease. This extraordinary ability challenges our understanding of aging and has fascinated scientists who study cellular regeneration and longevity. Some fish can change their gender as they mature. In many fish species, individuals possess the remarkable ability to change their sex during their lifetime. This phenomenon, called sequential hermaphroditism, allows a fish to switch from male to female or from female to male depending on environmental conditions or social structure. For example, clownfish are born male and can become female if the dominant female within their group dies. In contrast, some wrasser species begin life as females and later transform into males. This adaptation provides reproductive flexibility and helps maintain a healthy population balance. It also demonstrates the incredible adaptability of marine life in response to changing environments. The biggest mountain ranges in the world are underwater. Beneath the surface of the ocean lies a hidden landscape shaped by enormous mountain ranges that extend far beyond anything found on land. The mid-ocean ridges, for instance, form a continuous chain that wraps around the entire planet, and stretches for more than 65,000 kilometers, making it far longer than the Andes or the Himalayas. These underwater mountains are zones of intense tectonic activity where new oceanic crust is created as plates slowly pull apart. They influence ocean currents, marine ecosystems, and even global geology, reminding us of the powerful forces constantly shaping our planet. Some marine algae can grow over a meter per day. Certain species of marine algae, especially giant kelp, are capable of astonishing growth rates, sometimes increasing in length by more than 1 meter in a single day. This rapid growth enables kelp forests to form dense underwater environments that provide shelter and food for thousands of marine species. These towering underwater forests play a vital role in ocean ecosystems by supporting biodiversity, reducing coastal erosion, and absorbing large amounts of carbon dioxide from the water. Because of their fast growth and ecological importance, kelp forests are considered some of the most productive and valuable marine habitats on Earth. Towering kelp stalks offer shelter, nourishment, and nursery habitats for fish, invertebrates, and marine mammals. These underwater forests also play an important role in absorbing carbon, making them key contributors to marine ecosystem health and global climate regulation. The ocean contains more gold than all the gold mines on land. This may sound unbelievable, but the world's oceans contain an estimated 20 million tons of dissolved gold, exceeding the total amount of gold ever mined on land. Throughout history, this gold has been spread extremely thinly throughout seawater, existing at only a few parts per trillion, making it invisible to the naked eye and currently impossible to extract in an economically viable way. Gold enters the oceans through rivers, underwater volcanic activity, and hydrothermal vents, continuously cycling through marine systems. In some locations, gold becomes concentrated near specific underwater mineral deposits, sparking interest in potential future mining as technology continues to advance. For now, this vast oceanic reserve of gold remains a silent and hidden treasure, reminding us of the ocean's immense and largely untapped wealth. The deepest part of the ocean is deeper than Mount Everest is tall. The Mariana Trench, located in the western Pacific Ocean, is the deepest known point in the world's oceans. Its lowest section, known as the Challenger Deep, descends nearly 11 kilometers below sea level. To put this into perspective, Mount Everest, the tallest mountain on land, rises about 8.8 kilometers above sea level. If Everest were placed at the bottom of the Mariana Trench, its peak would still remain more than a kilometer underwater. The pressure at this extreme depth exceeds 1,000 times the pressure found at the surface, creating an environment so hostile that only specially adapted organisms can survive. Despite its isolation and harsh conditions, scientific expeditions have discovered unique life forms thriving in this abyssal realm, challenging our understanding of life's resilience. More than 80% of the ocean remains unexplored. Although the ocean covers more than 70% of Earth's surface, scientists estimate that over 80% of it is still unexplored and unmapped. This enormous unexplored region includes deep trenches, underwater mountain ranges, and vast abyssal plains that remain mysterious and poorly understood. Advances in technology, such as remotely operated vehicles, autonomous underwater drones, and advanced sonar mapping systems, have begun to uncover the ocean's secrets, regularly revealing new species and geological features. Even so, The ocean remains one of the planet's last great frontiers, holding countless unknowns that may reshape our understanding of biology, geology, and climate in the years ahead. Sea otters use rocks as tools to open shellfish. Sea otters are among the few animals known to use tools in the wild, and their preferred tool is often a simple rock. These intelligent mammals dive to the seafloor to collect shellfish, such as clams, sea urchins, and mussels. To break open the hard shells, they either carry a rock with them or use one resting on the ocean floor as an anvil. By striking or pounding their prey against the rock, sea otters gain access to the nutritious flesh inside. This form of tool use requires skill and learning, often passed down from mother to pup, demonstrating remarkable intelligence and cultural behavior among these marine mammals. More species live in the ocean than on land. The ocean represents the most biologically diverse habitat on Earth, with scientists estimating that it hosts millions more species than those found on land. From microscopic plankton to enormous whales, ocean life spans countless ecosystems, including coral reefs, kelp forests, deep-sea vents, and polar ice edges. Many marine species remain undiscovered, particularly in deep and remote regions, making the ocean a vast and largely unexplored reservoir of life. This incredible diversity supports complex food webs and plays a critical role in maintaining global ecological balance. The ocean's coral reefs are among the most diverse ecosystems on Earth. Coral reefs cover less than 1% of the ocean floor, yet they support roughly 25% of all marine species. Often called the rainforests of the sea, these vibrant ecosystems are built by tiny coral polyps that secrete calcium carbonate skeletons. Over time, these structures form complex habitats that provide food, shelter, and breeding grounds for fish, invertebrates, and algae. Coral reefs are essential for sustaining marine biodiversity and protecting coastlines from erosion and storm damage. However, they are highly sensitive to environmental stresses such as rising ocean temperatures and acidification, making their protection a global priority. Underwater volcanoes create new land and influence ocean chemistry. The ocean floor is scattered with thousands of underwater volcanoes, many located along the boundaries of tectonic plates. These submarine volcanoes erupt regularly, releasing molten lava that cools rapidly to form new crust. Over long periods of time, this volcanic activity builds underwater mountains and islands, continually reshaping the seafloor. In addition to creating landforms, volcanic eruptions release minerals and gases into the surrounding water, influencing ocean chemistry and supporting unique ecosystems. Hydrothermal vents near these volcanoes host extraordinary life forms that rely on chemicals from Earth's interior rather than sunlight, revealing hidden ecosystems thriving under extreme conditions. The ocean's thermohaline circulation functions like a global conveyor belt. This vast, slow-moving system of ocean currents is driven by differences in water temperature and salinity. Warm, salty surface water flows from the tropics toward the poles, where it cools, becomes denser, and sinks into the deep ocean. This cold water then travels along the ocean floor back toward the equator, completing a global circulation loop, often referred to as the conveyor belt. This process distributes heat and nutrients around the planet, playing a vital role in regulating climate and sustaining marine ecosystems. Any disruption to this circulation can have major consequences for global weather patterns and ocean health. Some deep-sea creatures can produce their own light. In the dark depths of the ocean, where sunlight never reaches, many organisms have evolved the ability to generate light through a process called bioluminescence. This natural glow is produced by chemical reactions within their bodies and serves a variety of purposes, including attracting prey, communication, and camouflage. For instance, the anglerfish uses a glowing lure to entice unsuspecting prey, while certain squid and jellyfish emit light to confuse predators. Bioluminescence is widespread in the deep sea and represents one of the ocean's most remarkable adaptations to permanent darkness. The ocean is home to animals larger than dinosaurs. The blue whale is the largest animal known to have ever existed on Earth. These gentle giants can grow up to 30 meters in length, or about 100 feet, and weigh as much as 200 tons, roughly equal to the weight of 33 elephants. Despite their immense size, blue whales feed almost entirely on tiny shrimp-like creatures called krill, consuming up to 4 tons per day during feeding seasons. Their hearts are as large as small cars, and their vocalizations can travel vast distances underwater. Blue whales serve as a powerful reminder of the ocean's immense scale and the extraordinary life it supports. Ocean salinity varies across different regions. Seawater is not equally salty everywhere, as salinity levels change depending on location, temperature, evaporation, and freshwater input. For example, the Red Sea is among the saltiest bodies of water due to high evaporation and minimal rainfall. In contrast, the Baltic Sea has much lower salinity because it receives large volumes of fresh water from rivers. These differences influence water density, ocean currents, and the distribution of marine life. Salinity also plays a crucial role in regulating ocean circulation and global climate systems. Some coral reefs are over 10,000 years old. Coral reefs are among the oldest living structures on Earth, with certain reefs continuously growing for more than 10,000 years. These ancient ecosystems have survived dramatic changes in sea level, climate, and ocean chemistry. They form the foundation of vibrant marine communities that support approximately a quarter of all ocean species. Their longevity and complexity make them vital for biodiversity, fisheries, and coastal protection. However, modern threats such as warming waters and pollution place these ancient reefs at serious risk, highlighting the urgent need for conservation efforts. The ocean is home to the largest living structure on Earth. The Great Barrier Reef, stretching over 2,300 kilometers off the coast of Australia, is the largest living structure on the planet. Built by billions of tiny coral polyps over thousands of years, this immense reef system supports an extraordinary range of life, including thousands of species of fish, corals, and marine mammals. Its vast size is so remarkable that it can be seen from space. Beyond supporting marine life, the reef protects coastlines from erosion and supports tourism and fisheries. Despite its importance, the reef faces severe threats from climate change, coral bleaching, and pollution, making its preservation a global concern. The deep sea is the largest habitat on Earth by volume. While the ocean surface covers most of the planet, the deep sea, defined as areas below 200 meters, constitutes the largest habitat by volume. It spans more than half of Earth's surface and contains over 90% of the ocean's water. This cold, dark, high-pressure environment is home to countless specialized organisms adapted to extreme conditions. Despite its vast size, The deep sea remains one of the least explored regions on Earth, with many species still unknown to science. Studying this habitat is essential for understanding the full diversity of life on our planet. Ocean dead zones are areas with extremely low oxygen levels. Dead zones occur where oxygen concentrations drop so low that most marine life cannot survive. These hypoxic regions are often caused by nutrient pollution from rivers and agricultural runoff, which fuels massive algae blooms. When the algae die and decompose, they consume oxygen in the water, creating inhospitable conditions. Dead zones can severely damage local fisheries and disrupt entire ecosystems. Their number and size have been increasing worldwide, posing a serious challenge to ocean health and to human communities that depend on marine resources. Hydrothermal vents support unique ecosystems powered by chemicals instead of sunlight. These underwater geysers are found near volcanic regions on the ocean floor and release superheated, mineral-rich water. Unlike most ecosystems that rely on photosynthesis, vent communities depend on chemosynthesis, where bacteria convert chemicals such as hydrogen sulfide into energy. These bacteria form the foundation of the food chain, supporting organisms like giant tube worms, clams, and unusual fish adapted to extreme environments. Hydrothermal vents challenge traditional assumptions about the conditions necessary for life. The sperm whale has the largest brain of any animal. The sperm whale possesses the largest brain by mass, weighing approximately 7 kilograms. This enormous brain supports complex behaviors, including deep diving, advanced communication, and intricate social structures. Sperm whales can dive more than 2,000 meters to hunt squid, using echolocation to navigate and locate prey in total darkness. Their intelligence and social complexity make them a key species for studying marine mammal cognition and the evolution of large brains. Ocean waves can travel thousands of miles without losing energy. Waves generated by wind blowing across the ocean's surface can travel vast distances, sometimes thousands of miles, while retaining much of their energy. These waves carry the force of distant storms to far-off shores, shaping coastlines and influencing marine environments. Swells created by Pacific storms can reach places like Hawaii or the coast of California, demonstrating the remarkable reach of ocean energy. This long-distance wave movement affects navigation, surfing conditions, and even the transport of nutrients in coastal waters. The ocean absorbs around 30% of human-produced carbon dioxide, helping to moderate climate change by acting as a massive carbon sink. Produced carbon dioxide. The ocean functions as a major carbon sink, absorbing approximately 30% of the carbon dioxide released by human activities, such as burning fossil fuels. This uptake helps slow global warming, but it also triggers chemical shifts in seawater, a process known as ocean acidification. Acidification can damage marine life, especially organisms that build shells or skeletons from calcium carbonate, including corals and shellfish. Scientists are examining how continued carbon absorption influences ocean ecosystems and what it could mean for the planet's climate in the future. The ocean holds nearly 20 times more carbon than the atmosphere. The ocean stores a staggering amount of carbon, roughly 20 times more than what exists in Earth's atmosphere. This immense reservoir plays a vital role in stabilizing the global climate. Marine plants, such as phytoplankton, absorb carbon dioxide through photosynthesis. And when these organisms die, Their carbon-rich bodies sink to the seafloor, locking carbon away for centuries or even longer. This natural storage process helps balance carbon levels, yet it is also influenced by environmental changes that can affect ocean health and climate regulation. The ocean's phytoplankton populations experience seasonal blooms visible from space. Phytoplankton in the ocean undergo dramatic seasonal blooms that can be so widespread they are visible from space. These tiny marine plants multiply quickly when conditions like sunlight and nutrient availability are ideal. Blooms energize the marine food web, supporting fish, whales, and many other forms of sea life. However, some blooms can become harmful, producing toxins that impact marine animals and humans. Satellites track these patterns to monitor ocean health and ecosystem change on a global scale. Mangrove forests protect coastlines and are crucial carbon sinks. Mangrove forests grow along tropical coastlines and provide essential protection against erosion, storm surges, and rising sea levels. Their tangled root systems hold sediments in place and soften the force of waves during storms. Mangroves also act as powerful carbon sinks, storing large amounts of carbon in their wood and soils, often far more per area than many land forests. These ecosystems support rich biodiversity, including fish nurseries and bird habitats, making them vital for coastal health and climate mitigation. The ocean's deep trenches are among the least explored places on Earth. Deep ocean trenches, such as the Mariana Trench and the Tonga Trench, represent some of the most mysterious and least explored environments on the planet. These narrow, steep valleys plunge thousands of meters below the surface and remain largely inaccessible because of extreme pressure and darkness. Even in these harsh conditions, scientists have found unique creatures adapted to life there. Exploring such trenches helps us understand the limits of life and Earth's geology, but much about these underwater abysses remains unknown. The blob is a massive patch of warmer water affecting Pacific Ocean weather patterns. The blob is a huge region of unusually warm water that appeared in the Pacific Ocean in recent years. This warm patch spans hundreds of miles and can disturb marine ecosystems by altering currents and changing the behavior of sea life. It has been linked to unusual weather along the west coast of North America, including drought conditions and shifts in fish migration. The blob shows how changes in ocean temperature can create wide-reaching effects on climate and ecosystems. The ocean can generate energy through tidal power and wave energy. The ocean is a vast source of renewable energy, with tides and waves offering promising ways to produce electricity. Tidal power captures the predictable rise and fall of ocean tides driven by the moon's gravity, using underwater turbines to convert this motion into energy. Wave energy uses the up and down movement of the sea surface to run generators. These technologies could supply clean power to coastal communities and reduce reliance on fossil fuels, although challenges remain in scaling up and limiting environmental impacts. Bioluminescent algae cause the phenomenon called sea sparkle. Sea sparkle is a captivating natural event created by bioluminescent algae, tiny marine organisms that emit light when disturbed. At night, waves or movement in the water can trigger these algae to glow with a soft blue-green light, creating shimmering sparkles along shorelines. This glowing display not only amazes observers, but also serves ecological roles, such as deterring predators or attracting mates. Sea sparkle appears in coastal waters around the world, offering a glimpse into the ocean's luminous life. The ocean's microplastics are widespread and affect marine life at all levels. Microplastics, tiny plastic particles less than 5 millimeters in size, are now found throughout the ocean, from surface waters to deep-sea sediments. These particles come from sources such as broken-down plastic waste, fibers from synthetic clothing, and certain personal care products. Microplastics can be eaten by marine animals of all sizes, from plankton to whales, causing physical damage and introducing toxins into food webs. Their widespread presence is a growing threat to ocean health and to the safety of seafood consumed by humans. The ocean produces over half of the world's oxygen. Although forests often receive the credit for oxygen production, the ocean actually generates more than half of the oxygen we breathe. This crucial role is mainly performed by microscopic plants called phytoplankton. These tiny organisms use sunlight to convert carbon dioxide into oxygen through photosynthesis. Despite their small size, phytoplankton are extremely abundant, forming the base of the marine food web and supporting life on Earth. Without their continuous oxygen production, the planet's atmosphere and ecosystems would look very different. The ocean's currents regulate global climate. Ocean currents behave like enormous conveyor belts, moving heat and nutrients across the world's seas. They help balance climate by transporting warm water from the equator toward the poles and returning colder water back toward the tropics. For example, the Gulf Stream carries warm Caribbean waters across the Atlantic toward Western Europe, keeping its climate milder than other regions at similar latitudes. Shifts in these currents can change weather patterns worldwide, sometimes contributing to extreme events like droughts or sudden cold snaps. The ocean has its own weather systems, including underwater tornadoes called vortices. Just like the atmosphere, the ocean experiences dynamic weather beneath its surface. One striking phenomenon is underwater tornadoes, known as vortices. These swirling bodies of water form when currents collide or flow around obstacles, creating powerful rotating columns that can extend for miles. Vortices influence marine life by mixing nutrients, redistributing heat, and shaping habitats. They play an important role in ocean circulation and in the distribution of organisms, making the underwater world as active and complex as the sky above. The ocean's abyssal plains are among the flattest places on Earth. Far beneath the waves, the seafloor includes vast, level regions known as abyssal plains. These areas can stretch across thousands of square kilometers and are considered some of the flattest surfaces on the planet. Formed by the slow settling of fine sediments over millions of years, abyssal plains typically lie at depths between about 3,000 and 6,000 meters. Despite the darkness and extreme pressure, these plains support diverse communities of animals adapted to life in this remote environment. Abyssal plains also play an important role in Earth's geology and in the functioning of ocean ecosystems. The ocean's ice sheets influence global sea levels and ocean currents. Massive ice sheets covering parts of Antarctica and Greenland contain enough frozen water to greatly affect global sea levels. When these ice sheets melt or grow, sea levels rise or fall, impacting coastal regions around the world. In addition, fresh water released by melting ice can influence ocean currents by changing the salinity and density of seawater. Such shifts can disrupt climate systems, marine ecosystems, and weather patterns, highlighting how tightly connected polar ice and ocean health truly are. Some sharks can detect electrical fields produced by other animals. Certain shark species can sense faint electrical fields generated by the muscle movements of nearby animals. This ability, called electroreception, helps sharks locate prey hidden beneath sand or in murky water when visibility is poor. Specialized organs known as the ampullae of Lorenzini detect these tiny electrical signals, giving sharks a powerful advantage while hunting. This sense makes sharks some of the most efficient predators in the ocean and shows how marine animals have evolved highly specialized tools for survival. The ocean's mesopelagic zone is known as the twilight zone. Between roughly 200 and 1,000 meters deep lies the mesopelagic zone, often called the twilight zone. Light here is extremely dim, not enough for photosynthesis, yet still sufficient to create a faint, eerie glow. Many organisms in this zone have large eyes adapted to low light, and some generate their own light through bioluminescence for communication, hunting, or camouflage. This region forms a key transition between the sunlit surface and the deep ocean, supporting unique ecosystems adapted to limited light. Coral spawning often happens simultaneously across entire reefs once a year. Many coral species coordinate a remarkable event known as coral spawning. During this time, corals release eggs and sperm into the water all at once, often synchronized by lunar cycles and water temperature. This mass release increases the chance of successful fertilization and creates a thick cloud of reproductive material that can be visible from boats and sometimes even detectable from above. This event is essential for coral reproduction and reef recovery, helping ensure the survival of these diverse yet fragile ecosystems. The ocean's kelp forests provide habitat for thousands of species. Kelp forests are dense underwater zones filled with large seaweeds called kelp. These forests form complex, three-dimensional habitats that supply shelter, food, and breeding areas for thousands of marine species, from tiny invertebrates to large fish and marine mammals. Kelp forests also help protect coastlines by reducing wave energy. They grow rapidly in cold, nutrient-rich waters and play a meaningful role in carbon sequestration, making them ecologically and environmentally important. Some squid use jet propulsion to escape predators at high speeds. Certain squid species rely on a powerful escape technique called jet propulsion. By quickly drawing water into the mantle cavity and forcefully expelling it through a funnel, squid can shoot backward at impressive speeds. This sudden burst of movement helps them evade predators fast and efficiently. Jet propulsion is a crucial survival strategy for squid in open water, combining speed and agility to escape threats in their environment. The ocean's salt mainly comes from volcanic activity and rock weathering. The saltiness of seawater largely comes from minerals delivered into the ocean over millions of years. Two major sources contribute to this process. Volcanic activity releases gases and minerals into the atmosphere and oceans, while the weathering of rocks on land dissolves minerals that rivers carry into the sea. These dissolved salts accumulate in ocean basins because water can evaporate, but minerals remain behind. The most common salt is sodium chloride, which gives seawater its familiar salty taste. This cycle has continued for billions of years, keeping ocean salinity at levels vital for marine life. Many marine animals use Earth's magnetic field for navigation. Several marine species can sense Earth's magnetic field, allowing them to navigate huge distances across the ocean with impressive accuracy. Sea turtles, salmon, whales, and certain fish detect magnetic cues that guide them to breeding grounds, feeding zones, and migration routes. This natural magnetic compass helps them travel thousands of kilometers through open water and, in many cases, return to the exact locations where they were born. Scientists are still studying how these animals detect magnetic fields, but it is clear that magnetoreception plays a major role in survival and reproduction. Some sea stars can regenerate entire bodies from a single arm. Sea stars have extraordinary regenerative abilities. If a sea star loses an arm due to injury or a predator, it can grow the limb back over time. Even more remarkably, some species can regenerate a whole new body from a single arm plus part of the central disc, as long as essential tissue remains. This capability helps sea stars survive attacks and maintain healthy populations. Regeneration relies on complex cellular processes that rebuild muscles, nerves, and skeletal structures, making sea stars an important subject of research into healing and biological repair. The ocean's plastic pollution can enter the food chain through tiny organisms. Ocean plastic breaks down into tiny fragments called microplastics, which are easily consumed by small organisms such as plankton and filter feeders. These creatures form the base of the marine food chain. When they ingest microplastics, pollutants begin moving upward through the food web. Fish, shellfish, and larger predators can accumulate plastics through their diets, potentially affecting health and survival. This contamination raises concerns about ecosystem stability and the safety of seafood for humans, underscoring the urgent need to reduce plastic waste. Ocean acidification threatens shell-building creatures like clams and crabs. As the ocean takes in carbon dioxide from the air, seawater chemistry shifts and becomes more acidic. This acidification makes it harder for organisms such as clams, crabs, oysters, corals, and other shell builders to form and maintain calcium carbonate shells and skeletons. More acidic conditions can dissolve the minerals these animals rely on, weakening shells and slowing growth. This creates serious risks for marine ecosystems and for fisheries that depend on shell-forming species. Scientists closely monitor ocean chemistry to understand and reduce the long-term impacts of acidification. The ocean's surface layer is only a few meters thick, yet it is crucial for life. The uppermost layer of the ocean, often called the surface mixed layer, is surprisingly thin, typically only a few meters deep, but it plays an essential role in sustaining life. This zone captures sunlight, enabling phytoplankton to photosynthesize and form the foundation of the marine food web. It is also the main interface between ocean and atmosphere, controlling gas exchange for oxygen and carbon dioxide. Even though it is thin, this layer influences weather, climate, and the health of marine ecosystems worldwide, making it one of the most important zones in the ocean. Many marine mammals use complex vocalizations to communicate. Whales, dolphins, and seals communicate using sophisticated sounds, including songs, clicks, whistles, and calls. These vocal signals can share information about identity, location, mating readiness, and social bonds. Some whale species produce haunting songs that travel hundreds of miles underwater, allowing communication across vast distances. Researchers study these sounds to understand behavior and social structures, and also to measure how human-made noise pollution affects marine mammal communication. The ocean contains underwater lakes and rivers with different chemistry. Beneath the ocean's surface, there are unusual features, sometimes described as underwater lakes and rivers. These are pools of water with a different chemical makeup, often much saltier or denser, trapped in depressions on the seafloor. Because of their higher density, these lakes and rivers do not mix easily with surrounding seawater and can flow along the ocean bottom, creating unique habitats. Scientists have found brine pools with extreme salinity that host specialized organisms adapted to harsh conditions, expanding what we know about ocean diversity. The ocean's overall salt content has remained stable for millions of years. Even though rivers and volcanic processes constantly add minerals, the ocean's salinity has remained remarkably stable over very long timescales. This balance is maintained through natural processes that remove salts, including the formation of mineral deposits and the work of marine organisms that incorporate salts into shells and skeletons. This long-term stability is essential for marine life adapted to specific salinity levels, and it also helps regulate currents and global climate patterns. Some fish can see ultraviolet light that humans cannot. Certain fish have evolved the ability to perceive ultraviolet, or UV, light, which is invisible to the human eye. This enhanced vision can help them spot prey, detect predators, and recognize mates in ways people cannot. UV sensitivity may also improve contrast in shallow, sunlit water and can support communication through UV reflective markings on their bodies. This adaptation gives these fish an ecological advantage and highlights the remarkable diversity of vision in the ocean. Whale songs can travel thousands of kilometers. Whales produce complex songs and calls that can travel extraordinary distances through the ocean. In some cases, these sounds can carry for thousands of kilometers, allowing whales to communicate across entire ocean basins. These vocalizations may serve as mating signals, tools for social bonding, and aids for navigation. Because visibility underwater is limited, sound becomes one of the most effective ways for these mammals to maintain contact. Scientists study whale vocal behavior to learn about populations and movement, supporting conservation of these majestic animals. Ocean currents can spread pollutants and marine debris. Ocean currents function like gigantic conveyor belts that transport not only heat and nutrients, but also pollution and debris. Plastics, chemicals, and other waste can travel thousands of kilometers as they are carried by surface currents into remote areas, where they can accumulate into large garbage patches. Because currents cross national boundaries, ocean pollution becomes a truly global problem. Understanding current patterns helps scientists predict where contaminants will move and supports efforts to reduce and clean up pollution. The ocean's largest predators often reproduce slowly. Many apex predators, including great white sharks, have surprisingly slow reproductive rates. They often mature late, sometimes requiring more than a decade to reach adulthood, and they produce relatively few offspring compared to many fish. This slow life cycle makes them especially vulnerable to overfishing and environmental change, because populations take a long time to recover. Conservation efforts are essential to protect these top predators, which play key roles in maintaining balance within marine ecosystems. Sea cucumbers help recycle nutrients on the ocean floor. Sea cucumbers may appear simple, yet they are vital for keeping the seafloor healthy. These soft-bodied animals crawl across the seabed, feeding on detritus, decaying plant and animal matter, and tiny organic particles within sediment. As they digest this material, they break it down and release nutrient-rich waste that fertilizes the seafloor. This recycling helps maintain nutrient balance for bacteria, algae, and other microorganisms, which in turn support larger marine animals. In many habitats, sea cucumbers act like ecosystem engineers, helping oxygenate sediments and preventing harmful substances from building up. Without them, the delicate network of life on the ocean floor could be thrown into collapse. The ocean's deadliest creatures often rely on venom or toxins for defense. Some of the most dangerous ocean animals do not depend on speed or size, but instead use powerful venoms and toxins to defend themselves or capture prey. Consider the box jellyfish, whose venom ranks among the most deadly and can cause heart failure in humans within minutes. The stonefish, often perfectly camouflaged on the seafloor, delivers venom through sharp spines that can cause intense pain and, in severe cases, death. Cone snails, which may look harmless, fire a venomous harpoon to immobilize prey almost instantly. These poisons evolved over millions of years, creating complex chemicals that target nervous systems. While frightening, these toxins are studied carefully because they may help develop new medicines, including pain treatments and therapies for serious diseases. It is a reminder that even the ocean's most dangerous creatures can inspire life-saving discoveries. Some marine plants can survive in extremely salty environments. Not all ocean plants live in moderate conditions. Some species have adapted to thrive in places where salinity is far higher than most life can tolerate. In salt marshes and coastal lagoons, where evaporation can leave water highly concentrated, certain plants and algae have developed strategies to cope. These include cells that push out excess salt or store it safely to prevent damage. Mangrove trees, for example, have complex root systems that filter salt from seawater, allowing them to survive in salty zones, while also protecting coastlines from storms and erosion. These salt-tolerant plants are essential for coastal ecosystems, offering habitat to fish and birds and storing large amounts of carbon that help reduce climate change. Their resilience shows how life can flourish, even in harsh conditions. The ocean's surface temperature has risen significantly over the past century. Over the last 100 years, human actions such as burning fossil fuels and clearing forests have increased greenhouse gases, raising global temperatures. The ocean's surface has warmed as well, with major consequences for marine life and climate. Warmer water can disrupt sensitive ecosystems, particularly coral reefs, which can bleach and die when temperatures exceed their limits. Fish and other animals may shift toward cooler regions, changing food webs and fishing grounds. In addition, warmer oceans can fuel stronger storms and hurricanes, altering weather patterns worldwide. Scientists track ocean temperatures closely because even small shifts can ripple through marine and land ecosystems, influencing sea level, biodiversity, and the health of the planet. Oceanic white-tip sharks are among the most aggressive species toward humans. Oceanic white-tip sharks are large, powerful predators found across tropical and subtropical waters. They are known for the white tips on their fins and for curious, sometimes bold behavior around people. These sharks have been linked to incidents involving shipwreck survivors and divers, where their persistence and investigative approach can escalate into aggression. Unlike some species that avoid humans, oceanic whitetips may be more likely to approach unfamiliar objects or individuals, which can be dangerous. Even so, they play an important ecological role as apex predators, helping keep marine food chains healthy by controlling populations of other animals. Unfortunately, oceanic whitetip sharks are considered vulnerable due to overfishing and habitat decline, reinforcing the importance of conservation. The ocean's microscopic viruses are the most abundant biological entities on Earth. Although invisible, ocean viruses exist in numbers so enormous that they outnumber all other biological entities combined. These tiny viruses are essential to ocean ecosystems because they infect bacteria and other microorganisms, controlling their populations and recycling nutrients. When viruses kill marine microbes, they release organic matter back into the environment, fueling microbial food webs. This continuous viral activity affects carbon cycling and helps maintain balance across ocean life. Scientists estimate there may be around 10 or 131 viruses in the ocean, making them the most abundant biological entities on Earth. Though unseen, these microscopic agents shape marine ecosystems in powerful ways. Some corals form symbiotic partnerships with algae that provide energy. Coral reefs are built by tiny animals called coral polyps, but their survival depends heavily on a close relationship with microscopic algae known as zooxanthellae. Some corals form symbiotic partnerships with algae that provide them with energy. Coral reefs are constructed by tiny animals known as coral polyps, but their survival relies heavily on a close relationship with microscopic algae called zooxanthellae. These algae live inside the coral's tissues and perform photosynthesis, using sunlight to produce energy. In return, the coral provides the algae with shelter and access to nutrients. This mutually beneficial relationship supplies corals with most of the energy they need to grow and build reefs. When environmental stress, such as rising water temperatures, disrupts this partnership, corals expel the algae, leading to coral bleaching. Without their algal partners, corals can starve and die, which threatens entire reef ecosystems. The ocean contains underwater mountains taller than many on land. Beneath the surface, massive underwater mountains called seamounts rise from the ocean floor. Some of these structures are taller than well-known mountains on land, yet remain hidden beneath the waves. Seamounts form through volcanic activity and can host rich ecosystems, attracting fish, corals, and other marine life. They also influence ocean currents by redirecting water flow, which helps transport nutrients. Despite their size and importance, many seamounts remain unmapped and unexplored, adding to the ocean's mystery. Sound travels faster in water than in air. In the ocean, sound moves roughly 4 times faster than it does through air. This is because water molecules are packed more closely together, allowing sound waves to pass more efficiently. Many marine animals depend on sound rather than sight to navigate, communicate, and find food in the often dark or murky underwater environment. Whales and dolphins, for example, use sound to maintain social bonds and locate prey. Human-made noise, such as ship engines and sonar, can interfere with these natural soundscapes, creating challenges for marine life. The ocean floor is constantly changing due to plate tectonics. The seafloor is not a static landscape, but one that is continually reshaped by tectonic activity. Along mid-ocean ridges, tectonic plates slowly move apart, allowing magma to rise and create new ocean crust. In other areas, plates collide, causing one to sink beneath another in a process called subduction. This movement drives earthquakes, volcanic eruptions, and the formation of deep trenches. Over millions of years, plate tectonics have played a central role in shaping ocean basins and influencing global geology. Some fish can survive being frozen in ice. Certain fish species living in polar regions have evolved extraordinary adaptations that allow them to survive freezing temperatures. These fish produce special proteins often called antifreeze proteins, which prevent ice crystals from forming inside their cells. By controlling how ice develops, these proteins protect tissues and vital organs from damage. This remarkable adaptation enables fish to survive in environments where temperatures drop below the freezing point of seawater. The ocean influences rainfall patterns across the globe. Large bodies of water play a major role in determining where and when rain falls. Evaporation from the ocean surface adds moisture to the atmosphere, which later condenses into clouds and precipitation. Ocean temperatures influence wind patterns and storm formation, affecting rainfall over continents. Phenomena such as El Niño and La Niña demonstrate how changes in ocean conditions can lead to floods, droughts, and shifting weather patterns around the world. Many marine species migrate vast distances each year. Ocean animals such as whales, sea turtles, sharks, and certain fish species undertake long migrations that can span thousands of kilometers. These journeys are often linked to feeding, breeding, or seasonal changes in temperature. For example, some whales travel from cold, nutrient-rich waters where they feed to warmer regions where they give birth. These migrations connect distant parts of the ocean and highlight how interconnected marine ecosystems truly are. The ocean stores heat and moderates Earth's climate. Water has a high capacity to absorb and retain heat, allowing the ocean to store vast amounts of thermal energy. This stored heat helps regulate Earth's climate by reducing temperature extremes between seasons and regions. Without the ocean's ability to absorb and redistribute heat, global temperatures would fluctuate much more dramatically, making the planet less hospitable for life. The ocean supports complex food webs that begin with microscopic life. At the base of nearly all marine food chains are microscopic organisms such as phytoplankton and zooplankton. These tiny life forms convert sunlight and nutrients into energy that supports every higher level of ocean life. Small fish feed on plankton, larger fish eat smaller ones, and top predators rely on the entire system below them. Any disruption at the base of this food web can ripple upward, affecting species throughout the ocean. This delicate balance highlights how even the smallest organisms play a critical role in sustaining marine ecosystems. Many deep-sea creatures have soft, gelatinous bodies. In the deep ocean, where pressure is extreme and food is scarce, many animals have evolved soft, flexible bodies. Jellyfish, comb jellies, and other gelatinous creatures require less energy to maintain and can survive in environments where rigid skeletons would be a disadvantage. These soft-bodied animals often drift with currents, conserving energy while capturing prey. Their unusual forms reflect the unique challenges of life in the deep sea. The ocean floor contains vast reserves of minerals and resources. Beneath the seabed lie large deposits of minerals such as manganese, cobalt, and rare earth elements. These materials are essential for modern technologies, including batteries and electronics. While interest in deep-sea mining has grown, scientists and environmental groups caution that disturbing the seafloor could damage fragile ecosystems that take centuries to recover. Balancing resource demand with ocean protection remains a major challenge. Some marine animals can live for centuries. Certain ocean species have exceptionally long lifespans. The Greenland shark, for example, is believed to live for hundreds of years, making it one of the longest living vertebrates known. Slow growth, cold environments, and low metabolic rates are thought to contribute to this longevity. Studying such animals may provide insights into aging and long-term survival. The ocean affects the chemistry of the atmosphere. Gases constantly move between the ocean and the air above it. Oxygen, carbon dioxide, and other gases dissolve into seawater and are released back into the atmosphere. This exchange helps regulate atmospheric composition and climate. Changes in ocean temperature and circulation can alter how much gas is absorbed or released, influencing global climate systems. Many fish communicate using sound. Although fish lack vocal cords, many species produce sounds by vibrating muscles, grinding teeth, or using swim bladders. These noises can be used to attract mates, warn rivals, or coordinate group behavior. Sound plays an important role in underwater communication, where visibility is often limited. Increased noise from human activities can interfere with these signals, affecting fish behavior. The ocean recycles nutrients through natural circulation. Nutrients such as nitrogen and phosphorus are constantly recycled through ocean currents, upwelling, and biological processes. When deep, nutrient-rich waters rise to the surface, they fuel plankton growth and support productive fisheries. This recycling system sustains life across vast areas of the ocean and links deep and surface ecosystems. Some marine species form lifelong bonds. Certain ocean animals, including some whale and seabird species, form long-term or even lifelong pair bonds. These partnerships may improve reproductive success and help raise offspring. Such social structures demonstrate that complex relationships are not limited to land animals. The ocean remains essential to human survival. Humans rely on the ocean for food, climate regulation, transportation, and cultural value. Billions of people depend on marine resources for their livelihoods. As human pressures increase, protecting ocean health becomes increasingly important for the future of both marine life and human society. The ocean plays a key role in Earth's water cycle. A large portion of the planet's water cycle begins in the ocean, where heat from the sun causes seawater to evaporate. This water vapor rises into the atmosphere, cools, and eventually falls back to Earth as rain or snow. Much of this precipitation returns to the ocean through rivers and groundwater, completing the cycle. This constant movement of water helps regulate climate, shape landscapes, and supply fresh water to ecosystems and human populations around the world. Many marine organisms rely on camouflage to survive. In the ocean, avoiding detection can be just as important as hunting successfully. Many fish and invertebrates have evolved camouflage that allows them to blend into their surroundings. Some species match the color of sand or coral, while others use patterns to break up their outline. Certain animals can even change color or texture to match their environment. This ability helps them avoid predators and ambush prey in a world where hiding can mean survival. The ocean supports vast fisheries that feed millions of people. Marine fisheries provide a major source of protein for people around the globe. Fish, shellfish, and other seafood are harvested from oceans to support local communities and global markets. Sustainable fishing practices are essential to ensure these resources remain available for future generations. Overfishing, habitat loss, and climate change threaten many fish populations, making responsible management increasingly important. Some marine animals can survive without oxygen for long periods. Certain species living in low oxygen environments have adapted to survive conditions that would be deadly to most animals. Some worms, mollusks, and microorganisms can slow their metabolism dramatically or switch to alternative chemical pathways when oxygen is scarce. These adaptations allow life to persist in environments such as deep sediments and oxygen-poor waters. The ocean helps buffer Earth from extreme temperature changes because water absorbs and releases heat slowly. The ocean acts as a massive temperature stabilizer. Coastal regions often experience milder climates than inland areas, with cooler summers and warmer winters. This buffering effect helps make large parts of the planet more habitable and reduces extreme temperature swings. Many marine species are still unknown to science. Scientists believe that a large portion of ocean life has yet to be discovered. New species are regularly found, especially in deep-sea environments and remote regions. Each discovery adds to our understanding of biodiversity and highlights how much remains to be learned about the ocean. The ocean connects ecosystems across the globe. Ocean currents, migrating animals, and drifting larvae link distant ecosystems together. What happens in one part of the ocean can influence regions thousands of kilometers away. Pollution, warming, and habitat changes can spread far beyond their point of origin, showing how interconnected the marine world truly is. The ocean inspires science, culture, and exploration. For centuries, the ocean has driven human curiosity and discovery. It has shaped cultures, inspired art and literature, and pushed scientific innovation. Even today, the ocean continues to challenge our understanding of life and the planet, reminding us how much remains unexplored. The ocean plays a central role in shaping coastlines around the world. Waves, tides, and currents constantly interact with land, slowly eroding cliffs, transporting sand, and forming beaches, deltas, and barrier islands. Over long periods of time, these processes can dramatically reshape coastlines, creating new landforms while wearing others away. Coastal landscapes we see today are the result of millions of years of interaction between land and sea, and they continue to change with every passing tide. Many marine animals depend on reefs and seafloor structures for shelter. Rocky reefs, coral formations, and underwater structures provide essential hiding places for countless marine species. Fish use these spaces to escape predators, lay eggs, and rest, while invertebrates attach themselves to hard surfaces for protection. Without these structures, many species would struggle to survive, highlighting the importance of preserving complex underwater habitats. The ocean helps regulate Earth's oxygen and carbon balance. Through photosynthesis, respiration, and chemical exchanges, the ocean plays a major role in maintaining the balance of oxygen and carbon dioxide in the atmosphere. Microscopic organisms absorb carbon and release oxygen, while physical processes move gases between water and air. This balance supports life on Earth and helps stabilize global climate conditions. Some marine species show advanced problem-solving skills. Dolphins, octopuses, and certain fish species demonstrate remarkable intelligence. They can solve puzzles, use tools, recognize individuals, and learn from experience. Octopuses, for example, are known to open jars, escape enclosures, and use objects as shields. These behaviors reveal a level of cognitive complexity that challenges traditional ideas about intelligence in animals. The ocean supports tourism and recreation worldwide. Millions of people travel each year to experience oceans through swimming, diving, boating, and coastal tourism. These activities provide economic benefits to many communities and foster appreciation for marine environments. Protecting ocean health ensures that future generations can continue to enjoy and benefit from these experiences. The ocean plays a role in Earth's long-term carbon storage. Over geological timescales, carbon absorbed by the ocean becomes locked away in sediments and rocks on the seafloor. This long-term storage helps regulate atmospheric carbon levels over millions of years. Disruptions to this process could alter climate stability far into the future. Many marine animals rely on seasonal cues for reproduction. Changes in temperature, daylight, and food availability often signal when it is time for marine species to breed or migrate. These natural rhythms help synchronize life cycles with optimal conditions. Climate change can disrupt these cues, potentially affecting reproductive success and population stability. The ocean remains one of the greatest sources of mystery on Earth. Despite advances in science and technology, vast areas of the ocean remain unexplored. New discoveries continue to reshape our understanding of life, geology, and climate. The ocean reminds us that our planet still holds many secrets waiting to be uncovered. Some corals form symbiotic partnerships with algae that provide them with energy. Coral reefs are created by tiny animals called coral polyps, but their survival depends strongly on a close relationship with microscopic algae known as zooxanthellae. These algae live inside the coral's tissues and use sunlight to produce energy through photosynthesis. In return, the coral offers the algae protection and access to nutrients. This partnership supplies corals with most of the energy they need to grow, build reefs, and maintain healthy ecosystems. When this relationship is disrupted by stress, such as rising ocean temperatures or pollution, corals expel the algae in a process known as bleaching. Without their algal partners, corals lose their primary energy source and may eventually die if conditions do not improve. These algae live within the coral's tissues and carry out photosynthesis, transforming sunlight into usable energy. The coral polyps receive nutrients produced by the algae, which supports their growth and helps them build the calcium carbonate skeletons that form reef structures. In exchange, the algae gain a safe environment and access to the coral's waste products, which they use as nutrients. This mutually beneficial relationship allows corals to survive and flourish in nutrient-poor waters where food is limited. However, when corals are stressed by rising temperatures or pollution, they may expel their algae, resulting in coral bleaching and threatening reef health across the globe. The ocean's sea ice covers roughly 7% of the surface, yet it plays a major role in climate regulation. Sea ice may occupy only about 7% of the ocean surface, but its influence on Earth's climate is far greater than its size suggests. Found mainly in polar regions, sea ice reflects sunlight back into space, helping regulate global temperatures and keep the planet cooler. It also provides essential habitat for polar species such as seals, penguins, and polar bears. As sea ice melts due to global warming, less sunlight is reflected and more is absorbed by the darker ocean water, accelerating warming through a feedback loop. Melting sea ice also affects ocean circulation and weather patterns worldwide. Scientists closely monitor sea ice as a sensitive indicator of climate change and a crucial component of Earth's environmental balance. Mangroves can filter salt from seawater to survive in coastal environments. Mangrove trees thrive in coastal zones where fresh water meets the sea, conditions that are too salty for most plants. To survive, mangroves have evolved unique adaptations that allow them to filter out salt. Their roots function as natural filters, blocking much of the salt from entering the plant. Any salt that does enter is stored in older leaves, which later fall off, effectively removing salt from the system. This remarkable ability enables mangroves to grow in salty, oxygen-poor soils where few other trees can survive. Mangrove forests protect coastlines from erosion, provide nursery habitats for fish, and store large amounts of carbon, making them essential for both marine ecosystems and climate regulation. Some fish can rapidly change color for camouflage or communication. Certain fish species have an extraordinary ability to alter their color and patterns quickly to blend into their surroundings or communicate with others. This rapid color change is made possible by specialized cells called chromatophores, which contain pigments that expand or contract. Camouflaging fish, such as cuttlefish or flounder, adjust their coloration to match the seafloor or coral reefs, helping them avoid predators or ambush prey. Color changes can also function as social signals during mating displays, territorial disputes, or warning behaviors. This dynamic form of protection and communication highlights the remarkable adaptations marine life has developed to survive in the ocean's diverse and competitive environments. The ocean's marine snow is a constant shower of organic material. From the surface to the deep sea, marine snow is a continuous fall of organic matter, drifting from sunlit waters down into the dark depths of the ocean. This snow is made up of dead plankton, fecal pellets, fragments of algae, and other organic debris. It serves as a vital food source for deep-sea organisms living far from sunlight. Although it sinks slowly, marine snow transports essential nutrients that sustain life in abyssal regions. This ongoing cascade links surface ecosystems with the deep ocean and plays a key role in the ocean's carbon cycle by moving carbon from the atmosphere into deep waters, where it can remain stored for centuries or longer. Seagrass meadows are among the most carbon-rich ecosystems on Earth. Seagrass meadows are among the most carbon-rich ecosystems on the planet. Seagrass meadows, found in shallow, coastal waters around the world, are some of the most efficient natural carbon sinks on Earth. These underwater grasslands capture and store large quantities of carbon within their roots and the surrounding sediments, a process often referred to as blue carbon. Seagrasses grow quickly and trap sediments, helping prevent coastal erosion while also improving water clarity. They provide essential habitats for fish, turtles, and many other marine species. The carbon stored within seagrass beds helps reduce climate change by locking away carbon dioxide that would otherwise remain in the atmosphere. Protecting and restoring these meadows is increasingly recognized as a powerful nature-based solution for lowering global carbon emissions. Some crabs use sea anemones as protective weapons on their claws. Certain crab species have developed a fascinating partnership with sea anemones. which they carry on their claws as living defensive tools. The crab benefits from the anemone's stinging tentacles, which discourage predators and competitors, while the anemone gains mobility and access to food scraps stirred up by the crab's movements. This cooperation provides the crab with an effective defense without needing to produce toxins itself. By waving the stinging anemones toward threats, these crabs can fend off attacks, demonstrating one of the ocean's many clever examples of evolutionary cooperation between different species. The ocean has giant barrel sponges that can live for thousands of years. Giant barrel sponges rank among the longest living animals in the ocean, with some individuals estimated to be more than 2,000 years old. These large barrel-shaped sponges filter enormous volumes of water each day, removing bacteria and organic particles while helping maintain healthy reef ecosystems. Their slow growth and extreme longevity make them natural record keepers of environmental change, as layers of their tissue capture chemical and temperature variations over centuries. Despite their ancient nature, giant barrel sponges are vulnerable to pollution, climate change, and physical damage, making their protection important for preserving reef biodiversity. The ocean's tides also influence some animal reproductive cycles. Many marine species align their reproduction with ocean tides, using the predictable rise and fall of water levels as environmental signals. Certain fish, crabs, and corals synchronize spawning events with high tides or specific lunar phases, ensuring larvae are carried away from predators and spread over wider areas. This timing increases reproductive success by matching suitable habitats and food availability for young organisms. The connection between tides and reproduction shows how deeply marine life is linked to ocean rhythms and to the gravitational forces of the moon and sun. Certain fish use electric fields to hunt or communicate. Some fish have evolved the remarkable ability to produce and detect electric fields, which they use for navigation, communication, and hunting in dark or murky waters. Electric eels, for example, generate strong electric shocks to stun prey or defend themselves. Other species, such as elephant fish and knifefish, emit weak electric signals to locate food and communicate with members of their species. This electric sense functions like a biological radar, allowing fish to perceive their surroundings through electrical impulses when vision is limited. It is an extraordinary adaptation that highlights the ocean's diverse sensory strategies. The ocean contains naturally occurring oil seeps that support unique communities beneath the surface. Natural oil seeps slowly release hydrocarbons into seawater, creating unusual ecosystems where specialized bacteria break down the oil and use it as an energy source. These bacteria form the foundation of food webs that support clams, tube worms, and other organisms adapted to these conditions. Communities surrounding oil seeps form habitats very different from typical marine environments. They demonstrate how life can adapt to extreme settings and exploit uncommon energy sources, showcasing the ocean's remarkable biological diversity and resilience. The ocean's surface layer is home to floating organisms known as the Newston. The Newston refers to a group of organisms that live at or just below the ocean's surface, occupying the boundary between air and water. This community includes tiny algae, bacteria, jellyfish larvae, and floating sea snails. Newstonic organisms play important roles in marine food webs by supporting larger animals and contributing to nutrient cycling. Because they inhabit this thin and dynamic layer, they are especially sensitive to environmental changes such as pollution and temperature fluctuations. Studying the Newston helps scientists understand how surface ecosystems connect to overall ocean health. Some marine worms build complex tube structures that support coral reefs. Some marine worms build complex tube structures that support coral reefs. Certain marine worms, such as the Christmas tree worm, construct intricate tubes made of calcium carbonate that become embedded within coral reefs. These tube structures provide protection and shelter not only for the worms themselves, but also for many small marine organisms. By creating these formations, marine worms increase reef complexity and biodiversity. Their presence helps stabilize reef structures and creates microhabitats that support a wide variety of life. Despite their small size, these worms act as important ecosystem engineers that contribute to the resilience and long-term health of coral reefs. Ocean waves are generated mainly by wind, but also by earthquakes and landslides. Most ocean waves form when wind blows across the surface of the water, transferring energy and creating waves that can travel thousands of kilometers. However, some waves originate from more dramatic events. Underwater earthquakes and landslides can trigger tsunamis, extremely powerful waves capable of moving at high speeds and causing widespread destruction when they reach shorelines. While wind-driven waves shape everyday coastal processes and marine navigation, tsunamis highlight the ocean's dynamic and sometimes violent nature. Certain jellyfish swarms can stretch for miles and affect local ecosystems. Some jellyfish species are known to form enormous swarms, often referred to as blooms, that can extend for miles across the ocean's surface. These blooms can strongly influence local ecosystems by competing with fish for food, clogging fishing equipment, and even interfering with power plant cooling systems. Jellyfish blooms may be driven by factors such as rising water temperatures, overfishing of predators, and nutrient pollution. Although their massive numbers can disrupt food webs, jellyfish blooms are also natural components of ocean dynamics, illustrating the delicate balance that exists within marine environments. The largest fish in the ocean is the whale shark, a gentle filter feeder. The whale shark is the biggest fish species on Earth, reaching lengths of up to 12 meters or about 40 feet, and sometimes more. Despite their enormous size, whale sharks are peaceful animals that feed primarily by filtering plankton, fish eggs, and small fish from the water. They swim slowly with their wide mouths open, straining food through specialized gill rakers. Found in warm and tropical oceans worldwide, whale sharks pose no threat to humans. Their massive size combined with their calm behavior makes them one of the ocean's most remarkable creatures. Some marine birds rely on ocean currents to travel vast distances with minimal effort. Many seabirds take advantage of powerful ocean currents and wind systems to move across huge distances during migration or while searching for food. Species such as albatrosses and petrels use a technique called dynamic soaring, which allows them to exploit wind gradients above ocean waves. This energy-efficient method lets them glide for long periods without flapping their wings. By harnessing winds and currents, these birds connect distant marine regions and play important roles in nutrient movement and ecosystem connectivity. The ocean's water cycle plays a major role in global rainfall patterns. The ocean acts as the driving force behind Earth's water cycle, constantly evaporating vast amounts of water that later fall as rain or snow over land and sea. This evaporation fuels weather systems and influences large-scale climate patterns, such as monsoons and hurricanes. Warm ocean waters provide the moisture needed for storms, while ocean currents help distribute this moisture around the planet. As a result, changes in ocean temperature can directly affect rainfall distribution, droughts, and flooding, impacting ecosystems and human societies worldwide. Some sea slugs can incorporate chloroplasts from algae into their own cells. Some sea slugs can incorporate chloroplasts from algae into their own cells. Certain species of sea slugs display a remarkable ability to steal chloroplasts from the algae they consume. These photosynthetic components are then stored within the slug's own cells. This process, known as kleptoplasty, allows the slugs to perform photosynthesis and generate energy directly from sunlight. Much like plants, these sea slugs can keep the stolen chloroplasts functional for weeks or even months, effectively becoming solar-powered animals. This unusual adaptation blurs the traditional boundary between plant and animal functions and highlights the surprising survival strategies that evolution has produced in the ocean's complex ecosystems. The ocean's coral skeletons preserve historical climate data similar to tree rings. Coral skeletons grow in layers, much like the annual rings of a tree, and each layer captures information about ocean temperature, chemistry, and nutrient levels at the time it formed. Scientists analyze these layers to reconstruct past climate conditions and better understand how ocean environments have changed over centuries and even thousands of years. By studying coral cores, researchers can track events such as El Niño cycles, ocean acidification, and long-term warming trends. This natural record offers valuable insight into climate history and helps scientists predict future changes, making corals important not only for marine ecosystems, but also for climate science. Some fish use sonic blasts to communicate or deter predators. Certain fish species are capable of producing strong sonic pulses by rapidly contracting muscles near their swim bladders. These sounds serve a variety of purposes, including attracting mates, communicating with nearby fish, or frightening potential predators. For example, the oyster toadfish produces a distinctive humming or boat whistle sound to establish territory and attract females. These acoustic signals can travel long distances underwater, overcoming the limits of visibility in dark or murky environments. This use of sound illustrates the diverse communication strategies marine animals have evolved to survive and interact. Ocean eddies can trap nutrients and support localized marine productivity. Ocean eddies are swirling bodies of water that may span tens to hundreds of kilometers and persist for weeks or even months. These rotating currents capture nutrients from deeper waters and concentrate them near the surface, creating pockets of high biological productivity. Such nutrient-rich zones support the growth of phytoplankton, which forms the base of the marine food web. Fish, seabirds, and marine mammals are often drawn to these areas to feed, making eddies important ecological features. By shaping nutrient distribution and ecosystem dynamics, eddies play a key role in sustaining ocean life. Some crustaceans practice complex mating rituals and parental care. Crustaceans, such as certain species of crabs and shrimp, engage in elaborate courtship behaviors that may include dances, vivid color displays, and even the construction of burrows or nests to attract mates. After fertilization, many crustaceans show parental care by guarding eggs, cleaning them, and carrying larvae until they are ready to survive on their own. This level of care improves the survival chances of offspring in challenging marine environments. These behaviors demonstrate the complexity of reproductive strategies among marine invertebrates, extending beyond simple spawning to include nurturing and protection. The ocean's hydrothermal vents emit chemicals that support entire ecosystems without sunlight. Hydrothermal vents are openings on the seafloor where superheated, mineral-rich water is released into the ocean. These vents create extraordinary ecosystems that thrive without sunlight, relying instead on chemosynthesis. In this process, bacteria convert chemicals such as hydrogen sulfide into energy. These bacteria form the foundation of food webs that support specialized organisms including giant tube worms, clams, and shrimp. Hydrothermal vent communities challenge traditional ideas about life by showing that ecosystems can flourish in complete darkness using chemical energy rather than sunlight. Salt water in the ocean is heavier than fresh water, which leads to layering. In certain regions, seawater is denser than fresh water because of its dissolved salts, meaning it has greater weight per unit volume. This difference in density causes layering in parts of the ocean, where saltier and heavier water settles beneath fresher, lighter water. This stratification influences ocean circulation, nutrient mixing, and the distribution of marine organisms. For instance, areas where river water meets salty seawater often develop distinct layers that affect plankton growth and fish behavior. Understanding these layers is essential for studying marine ecosystems and how they respond to environmental change. Some deep-sea fish have transparent heads that help them see prey above. A few species of deep-sea fish, such as the barreleye fish, have evolved transparent heads that allow them to look upward while keeping their eyes protected. This unusual adaptation helps them detect prey silhouetted against the faint light coming from above in the dark depths. Their tubular eyes can rotate inside the transparent dome, giving them a wide field of vision. This specialized anatomy is a striking example of how life adapts to extreme environments where light is scarce, enabling efficient hunting in the deep ocean's permanent darkness. The ocean's plankton populations are highly sensitive to temperature changes. Plankton, microscopic organisms drifting near the ocean's surface, respond quickly to changes in water temperature. Even small increases in temperature can influence their growth, reproduction, and geographic distribution. Because plankton form the foundation of the marine food web, temperature-driven shifts can spread through entire ecosystems, affecting fish, seabirds, and marine mammals. Seasonal plankton blooms depend on a precise balance of light and temperature, and rising ocean temperatures linked to climate change threaten to disrupt these essential cycles, with consequences for biodiversity and fisheries around the world. Many marine organisms use bioluminescence to communicate in darkness. Bioluminescence, the ability to produce light through chemical reactions, is widespread in the ocean, particularly among species living in deep or murky waters. Marine organisms use this glowing capability for many purposes, including attracting mates, luring prey, deterring predators, and signaling danger. For example, some squid emit rapid flashes to confuse attackers, while certain jellyfish produce a steady glow, that helps them blend with faint light from above. This natural illumination shows how ocean life has evolved to communicate and survive in environments with little or no sunlight. The ocean's surface microlayer is a unique habitat for specialized microorganisms. The surface microlayer is an extremely thin, nearly invisible boundary separating the ocean from the atmosphere. Although it is only a few millimeters thick, this layer hosts a diverse community of microorganisms adapted to its distinctive chemical and physical conditions. These microbes play important roles in gas exchange, nutrient cycling, and even cloud formation. Because the microlayer interacts directly with the air above, it is particularly vulnerable to pollution and climate change, making it a critical yet often overlooked part of the ocean ecosystem. Some marine algae can produce biofuels, offering sustainable energy potential. Marine algae, including certain seaweeds and microalgae, are being explored as promising sources of biofuels that could reduce reliance on fossil fuels. These algae grow rapidly and efficiently, convert sunlight and carbon dioxide into biomass, which can be processed into bioethanol, biodiesel, or biogas. Unlike land-based crops, marine algae do not require freshwater or agricultural land, making them a sustainable option that does not compete with food production. Ongoing research aims to improve algae-based fuel production and lower costs, potentially turning ocean plants into an important renewable energy source for the future. The ocean's dead zones are expanding due to pollution and climate change. Dead zones are areas of the ocean where oxygen levels drop so low that most marine life cannot survive. These zones have been increasing globally, largely because nutrient pollution from fertilizers and sewage triggers massive algae blooms. When the algae die and decompose, oxygen in the water is consumed, creating hypoxic conditions. Climate change worsens the situation by warming water and reducing oxygen solubility. Dead zones threaten fisheries, disrupt ecosystems, and reduce biodiversity, making it essential to understand and address their underlying causes to protect both marine environments and human livelihoods. Certain fish can live in both saltwater and freshwater, such as salmon. Some fish species, known as anadromous fish, spend parts of their lives in both freshwater and saltwater. Salmon are a classic example. They hatch in freshwater rivers, migrate to the ocean to grow and mature, and later return to their birthplace to spawn. These fish possess specialized physiological mechanisms that allow them to regulate internal salt balance despite changing environments. This ability lets them use a wide range of habitats and resources, but it also exposes them to threats in both freshwater and marine systems, including pollution, habitat loss, and overfishing. The ocean contains underwater canyons that are deeper than the Grand Canyon. Hidden beneath the ocean's surface are vast underwater canyons carved by ancient rivers, sediment flows, and tectonic activity. Some of these canyons, such as Monterey Canyon off the coast of California, are longer and deeper than the Grand Canyon itself. These submarine valleys create unique habitats for marine organisms, funnel nutrients and sediments from coastal areas into the deep sea, and influence ocean currents. Their steep walls and complex terrain make them hotspots of biodiversity, yet they remain largely unexplored because of their depth and inaccessibility. Some sea turtles use Earth's magnetic field to navigate thousands of miles. Sea turtles are remarkable navigators, traveling immense distances across the ocean to return to the same beaches where they were born to lay their eggs. Research has shown that turtles rely on Earth's magnetic field as a natural navigation system. By sensing subtle changes in magnetic intensity and inclination, they can determine both direction and location. This magnetic sense guides their long-distance migrations across open ocean, helping them reach precise nesting sites year after year, despite the challenges of featureless seascapes. The ocean's nutrient cycles are driven by the upwelling of deep, cold waters. Upwelling occurs when cold, nutrient-rich water from the deep ocean rises toward the surface. This process delivers essential nutrients such as nitrogen and phosphorus that support the growth of phytoplankton, the foundation of the marine food web. Regions with strong upwelling, including areas off the coasts of California and Peru, are among the most productive fishing zones in the world. By fueling photosynthesis in surface waters, upwelling plays a vital role in ocean ecology and global carbon cycling. Ocean acidification can affect fish behavior and predator avoidance. As the ocean absorbs increasing amounts of carbon dioxide from the atmosphere, seawater becomes more acidic. This chemical change can interfere with the sensory systems of fish, altering how they detect predators and navigate their surroundings. Studies have shown that some fish become less cautious and more vulnerable to predators in more acidic conditions. These behavioral changes can cascade through marine ecosystems, affecting predator-prey relationships and potentially influencing fish populations and fisheries that human communities depend on. Some marine species can live for more than 200 years, such as the Greenland shark. The Greenland shark is one of the longest living vertebrates known, with estimated lifespans exceeding 2 centuries. These slow-growing sharks inhabit the cold, deep waters of the North Atlantic and Arctic Oceans. Their exceptional longevity is linked to their slow metabolism and frigid environment. Studying such long-lived species provides valuable insight into aging processes and the long-term effects of environmental change on marine life. The ocean's surface reflects about 6% of incoming solar radiation, influencing climate. The surface of the ocean reflects a portion of the sun's energy back into space, a property known as albedo. On average, roughly 6% of incoming solar radiation is reflected, depending on factors such as wave conditions and the angle of sunlight. This reflectivity affects Earth's overall energy balance and plays a role in regulating global temperatures. Changes in surface conditions, including melting sea ice or variations in cloud cover, can alter reflectivity and influence climate patterns. Certain marine bacteria can break down plastic, offering hope for pollution reduction. Plastic pollution is a growing challenge in ocean environments, but some marine bacteria have demonstrated the ability to break down plastic materials. These bacteria produce enzymes that degrade plastics such as PET into smaller, less harmful components, although this natural process is slow and not yet a complete solution. Studying and potentially harnessing these microbes could lead to new technologies for reducing plastic waste and mitigating pollution in marine ecosystems. As our journey beneath the waves comes to an end, allow the quiet immensity of the ocean to settle gently in your thoughts. This vast, life-filled world continues its slow movements beneath the surface, holding countless mysteries still waiting to be discovered. May the steady rhythm of the tides and the soft whisper of ocean currents guide you into deep, restful sleep. Thank you for joining this calming exploration of the ocean's wonders. If you enjoyed the journey, consider liking and subscribing to the Relax Galaxy Moments channel, where curiosity meets calm each night. Sleep well, stay curious, and until next time, let the ocean's gentle embrace carry you peacefully through the night.